6.5 Solving linear systems by multiplying first. Sometimes with these linear systems, you are going to have two equations where neither of those variables cancel each other out. So when that is the case, you are going to have to multiply both equations or just one of the equations by a number or a number and is an opposite sign of something in order to cancel out variables. If we look at example A, we have 3x plus 8y is equal to 7, and 2x minus 2y is equal to negative 10. So if you look here, you have two y's that are opposite signs. You can multiply 2 by something to get 8. So we would multiply that bottom equation by 4 in order to get y's that cancel out. That first equation, that 3x plus 8y is equal to 7 is not going to change. So that bottom one, we just distribute that 4 in. 4 times 2x is 8x. 4 times negative 2y is negative 8y. And 4 times negative 10 is negative 40. So we go to combine these. The 3x plus 8x gives us 11x. The 8y minus 8y cancels. And negative 40 plus 7, or 7 minus 40, is negative 33. So we divide each side by 11 here, and we get that x is equal to negative 3. From here, we're going to plug that negative 3 in to get what y is. So use one of the original equations, either the 3x plus 8y is equal to 7, or the 2x minus 2y is equal to negative 10. I'm just going to plug it into our first equation, so it's going to be 3 times negative 3 plus 8y is equal to 7. The 3 times negative 3 is negative 9. Plus 8y is equal to 7. We're going to move the 9 over by adding it to both sides. We have 8y is equal to 16. And then we divide each side by 8. And we get that y is equal to 2. So this gives you the ordered pair of negative 3, 2 for a solution. For B, we have negative 3x plus 2y is equal to 4, and 4x minus 13y is equal to 5. So I would look at your numbers that are smaller coefficients. So I have a negative 3 and a 4. In order to cancel those out, they are opposites. We can go ahead and multiply the 3 by something and the 4 by something. You want to look at their least common factor, or their least common multiple. So least common multiple between negative 3x and 4x is 12x. So we are going to multiply the top by 4 and the bottom by 3. So both of these equations are going to change now. So if we distribute the 4 into the top equation, we're going to have negative 12x plus 8y is equal to 16. The bottom one, 3 times 4x is 12x. So those are going to cancel. 3 times negative 13y is negative 36y. And 3 times 5 is 15. So we are going to add these now. These 12x's cancel. 8y minus 36y. Oh, sorry, this is 39, not 36. 39. Here, let's do this. There we go. All right, so 8y minus 39y is going to give us a negative 31y. And then we have 16 plus 15, which is 31. We divide each side by negative 31, and we get that y is equal to negative 1. We're going to plug this into one of the originals. I'm going to use the bottom one for in this case. So I'm going to have 4x minus 13 times negative 1 is equal to 5. The negative 13 times negative 1 is positive 13, so 4x plus 13 is equal to 5. We move the 13 over by subtracting it, and we get 4x is equal to negative 8. Divide each side by the 4, and we get that x is equal to negative 2. So our solution for this one is negative 2, negative 1, x, then y. Negative 2, negative 1. If we look at our next example, we have 4x minus 5y is equal to 23, and 3x plus 10y is equal to 31. The x's are not opposites, the y's are, so the top one, the negative 5, I can multiply that by 2 to give me negative 10 and cancel out those two y's. So I'm going to distribute the 2, and this is going to give me 8x minus 10y is equal to 46. The bottom is going to stay the 3x plus 10y is equal to 31. So from here, I'm going to add them. The 8x plus 3x is going to give me 11x. The 10y's cancel, and 46 plus 31 is 77. We divide each side by the 11, and we get that x is equal to 7. From here, I am going to plug this 7 into the top equation, so I'm going to have 4 times 7 minus 5y is equal to 23. Though 4 times 7 is 28, minus 5y is equal to 23. I move my 28 over. We subtract it from each side. I'm going to have negative 5y is equal to negative 5. We divide each side by negative 5. And I get that y is equal to 1. So if x is 7 is 1 and y is 1, we're going to have 7, 1 as our solution. For D, we have 3a plus 4b is equal to 2, and 5a plus 9b is equal to 1. I want to work with my a's, so I need to make sure that they're opposites first, which they're not. So one of these equations I'm going to have to multiply by negative. Now 3 and 5, what's my least common multiple between these two? 15. So I'm going to have to multiply the 3 by 5 and the 5 by 3, but a negative 3, in order to get opposites but the same variable, or the same coefficient to the variable. So I multiply the 5 in to the top. I'm going to have 15a plus 20b is equal to 10. Multiply the negative 3 to the bottom. We're going to have negative 15a minus 27b is equal to negative 3. From here, I'm just going to combine like terms. The 15a's cancel. 20b minus 27b is negative 7b. And 10 minus 3 is 7. Divide each side by negative 7. We're going to have b is equal to negative 1. Choose one of the equations to plug into. I'm going to use the top. So we're going to have 3a plus 4 times negative 1 is equal to 2. We have 3a minus 4 is equal to 2. I add that 4 to both sides. And we get that 3a is equal to 6. We divide each side by 3. And we have that a is equal to 2. So again, remember, alphabetical order with these ordered pairs, our solution is going to be 2, negative 1. For E, we have negative 3x plus 4y is equal to 12, and 2x plus y is equal to negative 8. Now, look at your two terms. Your two variable terms, that we have here are x and y. Do any of those x's or y's have opposite signs of each other? Yes, the x's. So because the x's are opposites, use those. It'll be a lot easier to go ahead and find your least common multiple. Between the negative 3 and the 2, our least common multiple is 6. So the 3, we're going to multiply by 2. The 2, we're multiply by 3. So this is going to give us negative 6x plus 8y is equal to 24, as well as 6x plus 3y is equal to negative 24. When we do these, the x's cancel, so we're going to have 10y is equal to 0. From here, divide each side by 10, and y is equal to 0. Choose one of the equations, plug it in. I'm going to choose the bottom one. So we're going to have 2x plus 0 is equal to negative 8. This is the same thing as 2x is equal to negative 8. And then divide by 2. We get that x is equal to negative 4. So my solution is negative 4, 0. This next equation we actually already did. If we look at our next example, we have 5 over 3 x plus y is equal to 7, and x plus y over 4 is equal to 7 over 2. If you want, you can get rid of these fractions. The only thing you'd have to do is multiply the entire top equation by the least common denominator there, so that would be 3. Bottom equation would be 4. So this is going to give us 5x plus 3y is equal to 21, and 4x plus y is equal to 14. From here, we're going to multiply that bottom equation by negative 3 to cancel out those y's. So we're going to have 5x plus 3y is equal to 21, and negative 12x minus 3y is equal to negative 42. From here, combine your like terms. The 5x minus 12x is negative 7x. The 3y's cancel. 21 minus 42 is negative 21. So from here, I'm going to divide each side by that negative 7. And I get that x is equal to 3. Now I'm going to plug this into one of those equations. I'm going to use the bottom. Actually, I'm going to use the top one. So I'm going to have 5 times 3 over 3 plus y is equal to 7. So that those 3's cancel. I'm going to have 5 plus y is equal to 7. I'm going to subtract each side by the 5. And we have that y is equal to 2. So this gives me the ordered pair of 3, 2.